Okay, everybody. My name is Theo Samuel. I'm from Argon University. I'm a mechanical engineering student. And today I am going to teach you about vector and scalar quantities. We're going to discuss today. So, what is vector and the scalar quantity? The difference between them in their definition and some examples. Let's start with scalar quantity. What is scalar quantity? Scalar quantities have only magnitude. They have only what?
Magnitude.
Magnitude, or which means size, amount, or value. Or size, amount of something, or value of something. We call it what? A scalar quantity. Let's see examples. The first one, mass. Mass is a scalar quantity. Mass is a scalar quantity. Example, 1 kilogram of sugar, or 5 kilogram, 5 kg of sugar. So there is no any other extra information about this 5 kilogram sugar. So it's 5 kilogram. So there is no direction. It is only scalar quantities have only magnitude. Let's see some other examples. Temperature, like example 30 degrees Celsius. Okay, speed. Speed is on a scalar quantity. Symbolize it like this: V. Time, energy, and so on. Scalar Scalars do not have direction, just a number with a unit. Do not have direction, just they have a number and units. Just numbers and units. No direction. Change the Parker. And I'm gonna use this pen. So let's talk about vectors. Vector quantities. So let's start with the definition of vector quantities. A vector quantity has both magnitude and direction. With both magnitude, magnitude, and what?
Direction.
Directions. Yes, guys. With both magnitude and direction. What? A vector quantity. So let's see some examples. Velocity. Velocity. Let's describe velocity. 60 kilometer to where? 60 kilometer east. I walk every day 60 kilometer from school to home. Take the difference with the speed. This is the speed. Someone walks 60 kilometer from school to home. This describes only without only the magnitude 60 kilometer, but in here with the velocity, someone walks 60 kilometer. I walk 60 kilometer to the east, 60 kilometer to home at to the east direction, to the east direction. So here's what makes it different from the speed. The velocity has
Direction.
directions. So take another example. Face force. Force. Example 10 Newton. 10 Newton. Someone pushes with 10 Newton something to or upward. If I push something with 10 Newton and I lifted it up, the thing that I pushed to the upward side has a mass of 1 kilogram. It must be 1 kilogram, and the energy, the force that come out of me is going to be 10 Newton. So the force is upward direction. So let's see another example. Acceleration. Acceleration. See what acceleration means. Acceleration is the rate change of velocity. The rate change of velocity. Okay. Example: 3 meters per second square downward. Word. What this mean? What's 3 meters per second square downward? This means something thrown from the above. Let's say it is in Mars planet. So here is the Mars planet. It's the ground of the Mars planet. Then someone drops something. It comes, let's say, with this acceleration. Let's consider no air resistance in here. So someone drops something in Mars planet. This is Mars. So it goes 3 meters per second. This means this ball, if someone drops it at with zero velocity, it starts with zero velocity in here. If it is zero, then it changes in every second. In every second, it changes 3 meters per second speed. It adds from this to this. From this to this, it takes, let's say, 1 second. From this to this, it say, let's say, takes 2 seconds, 3 seconds. This is the ground. So in here, the speed will be 3 meters per second. It is simultaneously, by the way. Then after this, when it gets here, we didn't calculate the head, but just according to time, at 2 seconds, the speed will be added, or the speed changes in how many, in how much quantity? In 3 meters per second. So 3 meters. When we add 3 plus 3, so it becomes 6. So in here, 6 meters per second the speed will be. So what is acceleration means? Acceleration is the change in velocity with respect to time. 3 meters per second square downward. This means in every second, this ball speed is up. In each second, 3 meters per second speed will be added on the first initial velocity. What if the velocity is 1 meter per second? It will be, in here, it will be 4 meters per second. It's 4 meters per second. In here, it will be how much? 7 meters per second. So this is the concept of acceleration. I will discuss this later in another time. Quantity, let's come to the point. It has 3 meters per second square, 3 meters per second change. In each second, this square tells about that. In each second, at what direction? Down direction, downward, to the Earth or to the Mars. So this is the concept between scalar and vector quantities. Scalars have magnitude, no directions. In vector has magnitude in with both directions. Vector has number, units, and direction. When we come to Scalar, there is a number in only units. So this number shows about the magnitude. The magnitude can be size. Let's example, let's take meter distance. The magnitude maybe can be amount in here, kilogram, mass. The magnitude will be volume. It will be temperature less 30 degrees Celsius. So scalar quantities have only magnitudes and the vector quantities have
Both magnitude.
both magnitude and direction. This is the difference between vector and scalar quantity. Thanks for listening. I'm from uh, Urban University, mechanical engineer student, and I love to teach and study physics. It's my hobby. Thank you for watching. Later.